So welcome to Top-Down Consulting's K-Scope 16 Encore presentation of drill through. It may not be as hard as you think. Today's presenters are Michael Smith and Ron Moore. Michael and Ron will answer questions at the end of the presentation, but you can ask them anytime during the presentation by typing them in the question box located on your GoToWebinar panel. And with that, I will turn things over to Michael and Ron.
Hello, and welcome to the presentation. This was a project actually that we did that was kind of leveraging a creative process I'd come up with in a prior client to help mapping, basically leveraging mapping in the back end of FDM and FDMEE, and we found a even more creative use here, and we'll go ahead and get started, and we'll discuss some more of that about that specific. Target application, and that's where you can actually have fairly complex mappings, and it also we're actually using the back end to kind of do a reverse mapping off of that post-mapped data, if you will. After you load the data into FDM and FDMEE inside the tables, it actually stores the original dimensional members as well as what you are now mapping them into in the Oracle and Hyperion tools. That's what we're actually using. Essbase Studio just a quick overview is it's a tool that you can use to create a cube from basically a relational star schema. Internal into the tool, it does have some drill down and drill through capabilities. It's basically drill down into the table, but you can replace what you're drilling down to, and that's kind of how we're creating the drill through capabilities. But what this tool will actually spin up a cube for you out of the dimensional members in the star schema, and then the actual data records that are also stored in that star schema. Okay, the original project, when we walked onto the site, the way that they had built the cube, they would take the source system data, and it actually came from about 12 different instances of Microsoft Dynamics, and they would load those into HFM using FDM and later FDMEE. The resulting data is also created and it's loaded into a file. It actually, FDM and FDME creates a separate data file that you can actually access that's used to load into HFM. You can actually grab that file and then load it into a cube as well, and that's what they've done. Now, the dimensions in that cube were largely manually maintained. They were initially loaded and then maintained manually, and that was something that they wanted to address greater part of our project. And so we'll go into now the actual what our end result was after we finished this project. Introduced schema, FDMEE Studio, and then we loaded just some sample data into the fact table. We didn't really care about the data that was there. We just needed it to be able to create the cube with the dimensions, and then we would actually be overriding all that data anyway. So we just created that original as an ASO cube. We built the outline using Studio from DRM loaded tables, so it became a much better, easily maintained process. And then we actually deploy the cube from Studio. And after that's deployed, the data is actually then loaded in just like it was before from that file. Now, what this did was it provided us that opportunity to have a much better maintained process. The outline was better maintained, and also and a much easier maintenance. So now we're going to step into kind of the design of the actual data, the source system data. And what we had them do was to bring all of the data from the 12 different DAX instances together. The reason we had to do that was we could not access the data spread out as it was due to a lot of their security concerns, also network latency as it was scattered all over the world. So one of the things we had them do was to bring all of that source system data together into a single set of tables. Not really a DAX instance, but a single set of tables that we could then access. And now they have a process that keeps that set of tables in sync. We could actually filter down some of the data because of specifically what they were targeting to drill back to. We didn't have to necessarily pull all of the data, though that's definitely possible. And then, so now we'll start going into some of the mapping and the way that process itself works. Data itself is loaded into FDM and FDME, and it populates from and two dimensional columns, as well as a data column with the value that you're actually populating. The from, it actually can have a lot of concatenated source dimensions. You don't necessarily have account A equals account B. It doesn't have to be that simple. You can actually have take an account, combine that with a cost center and a profit center, and then that results in the location, for example. So it can be a concatenated set that you go through some complex, not necessarily calculations, but it can be. It can be a set of case statements and if statements that are written into the actual script. But the ultimate item that we're looking for is what were the source dimensions that were involved in this calculation, and then what did it actually land on? What was the two dimension that it actually landed in an ASO and into our Hyperion tools? And we'll go into a little bit of some examples here, and you'll see how the complexity can be broken down. So you do have some mappings that are one-to-one, and that's fine, easy to do. And it might you might be just adding a prefix, for example, in FDM, FDMEE. But some of them actually might utilize multiple dimensions, as I discussed. And here's an example where they use the profit center, district, count, and the entity to come up with a cost center, for example. Now, what we're going to next show you is how this then reverses back into our where we can actually find out the ASO member and go backward to where the original data members were. What we decided was we came up with to go into the details in the back end real quick, is the way it's stored, as you see here in the UD2 from and to, is there are two different columns that matter in the back end. One of them is the UD2. That is actually stores the concatenated string that is used to derive the ASO or the map2 value. And you'll see that they're actually stored here, and you can see the example. Well, one of the things that we decided to do was maybe we can make this a little easier on ourselves, and we would go and break this down into an unused user-defined column, and we'll concatenate it with pipes. So then we can load into this UD19, we'll load in all the individual dimensions, and then we'll have and then we won't have to look for those anymore. We won't have to go back and try to rip apart the UD2 column, for example, for the profit center of 999. I'll just go to the UD19 in this case and know that that's the first item in this pipe delimited string. So that made our life quite a lot easier, and we'll go into a little bit of that breakdown here. So I pull it into this UD19, and I can easily rip apart that UD19 into these different items, as you can see, just because of the pipe delimited and predefined format of that column. And that column, exists in FDM as basically a lookup column. You can create some of those in FDM that aren't being connected to any source system. You're not loading this into HFM. You're not loading anything into using it to load into ASO or anything. It's actually just there for the purpose of FDM to do a lookup. So it's a column that you yourself can control, and you don't have to worry about it impacting any of your implementation. So then the next thing I do is I created a mapping table. And then what I'm doing now is I'm pulling all of the dimensions that are the original DAX dimensions, and then I'm pulling, so they're the from, if you will, and then I'm pulling all the ASO dimensions, which are the to. And by looking at that whole string of all of the, if you will, the complex key, all the whole set of keys that are involved in mapping the from and to for all the dimensions, you make kind of a unique set of keys. So I decompose that original source dimensions in the from and do that, make it my job easier. I use that UD19, and then I load the Essbase dimensions in the to columns. And you can put them in a table, you can index it, and so that one becomes kind of your master map. You don't really care about the data values because you still are going to be able to get those from the ASO cube, and you're not really involved in the data side. You just want the mappings from this back end. And now we're going to connect the data itself to the maps, and that's where kind of the magic kind of brings itself together, if you will. What you do is in a view, you're going to join. You have your source data, and you're going to join to that source data using the DAX dimensions that are in this mapping table. And by doing that, you now also know what the ASO equivalent or the mapped to ASO dimensions are in those members. So now you can look at this data using either DAX or ASO dimension members, and you can see you can actually pull out either way using either set. You can pull out the actual source records that made up that aggregated into that intersection. Now here's how, when you bring in the maps, you have the FDM schema and you're going to bring in and connect it to the maps themselves. And then here you're actually creating the data views, and again that you can join and look at it from either set. And remember, this is sitting in a relational database, so I can create a query starting with either set of dimensions, and that really helps out a lot when you're trying to debug and trying to do a little bit of research on your own as a developer. You can look at it from either way now, either from the ASO Hyperion world, or you can look at it from the DAX world and verify that you've got the right set of data. The next part is actually creating using Essbase Studio. You want to now create a drill through report. And I'm not going to go into any of the real details here. Basically, you'll go through in Studio after you've created the cube, and you can go select a drill through report. You're going to create that. The important part for me is you can select now this template SQL, and that's how Studio would normally call and execute this drill through report. It's going to try to execute it against the table that was used to create the actual cube, but in this case we're going to change that template SQL, and that's where you actually can now leverage the view you created to do the mapping. And here's where you take that view that joins the map and DAX data together. You add it in as an additional fact table within Studio, so that now that it is included into the template SQL, and it's shown up. It'll show up as one of the items that you can now include while you're building your SQL statements that you're later going to put back in place of this template SQL. It becomes then your custom SQL in there. So you generate your template SQL out of Essbase Studio, and this is you're not even attempting to show you the details of that in the slide, what it looks like. You're going to edit the custom SQL to use this map to the DAX mapping view, if you will. And then now, when you're going to actually go and build the Smart View reports, add that drill through to the cells themselves, and then now you'll be able to drill through. It'll actually call back to the map, to the DAX data view. Here's an example with the Essbase Studio, the drill through report itself. When you right click on the Smart View and you select the report that's defined for that intersection, the result set it's actually going to appear in a new tab in that sheet. And let me go to I'm actually going to have to break out of this presentation and go to another PowerPoint, because this one didn't have some of the details that I wanted to go through, that actually has some of the maximize this. Come on. It didn't have some of the details I wanted to go through on the actual code. Apologize for this. Right now, are there any questions already regarding this? I don't know why I don't have that in this.
Just a reminder while Michael's doing this, if you do have questions, just type them in the question box and we can go ahead and read them off. And he or Ron can answer them.
Trying to maximize this screen. Here we go. Okay. Do you see the PowerPoint slide? I mean the PDF slide? Okay. Here we go. I don't know why this was not in the one I was going through. I forgot about it as I was digging through. So let's go back into a little bit of the pulling the keys. When you're pulling the keys and you're incorporating it into the actual data, this now shows you what the some of the code that you're going to use. In this case, it's actually pulling the mapping data from the relational, the FDMEE back end. So you're actually pulling this data and you're going to load it into a table. And you can see all we're doing is we're pulling the from and to. So in this case, the account and account X, entity X, the UD1, 1X, etc. And we're actually pulling that from two of the FDM sources, and we load that into our actual mapping table. And then to change it to FDMEE, we actually had to go and change some of the joins and the source. But what we started doing is we actually put it into the UD19 column, as I described before. And that way it actually, it makes it just so much easier for you to do your mapping, because you no longer, what we ran into was when we were part of the mapping, we had cases where FDM would either drop off some of the, if you had an underscore or some of the delimiters you might have had within your complex concatenated string, it would drop some of those out if one of them overran the size that it expected it to be, and that made it really hard to rip a string apart. And we said, why do that? We don't need to rip these strings apart. We'll just load them into our own column and predefine with the pipe delimiters how to concatenate them together, and that made it a lot easier. And then here's some of the way that we were extracting the mapping data. This is an example of how before, whenever we were ripping apart the complex concatenated string, you had a lot of code, a lot of unnecessary code, just trying to find where an underscore was. Did it have an underscore A at the end or an L to prefix it? And the new one, literally on the very bottom, you see it. I usually have a split string function. I tell it, go to UD19 and give me the third item within that string, and that's it. That was as simple as. So it's a big change, leveraging that kind of lookup column, if you will, in FDMEE. And then again, just mapping from FDMEE, it became pretty simple. So let me go some of the mapping, that data view I spoke about. In here, this is the actual view where you're joining the map to the actual ledger transaction table. It was as simple as joining that map where you're joining the DAX dimensions. And in this case, you'll see the data area ID, account num, dimension 3 underscore, dimension 2 underscore, and then also a transaction date. It used the date range. So in my mapping table, I actually included the date range as the beginning of one month and the beginning of the next month, so I could capture the entire month's data when I join. And all of this is done in the data view, so that you don't have to deal with this when you're trying to write your custom SQL coming out of Essbase Studio. And again, all of this is in the presentation that we would have. If you want to reach out to us, we can provide all this information. So again, this was to go back to the drill through reports, the custom SQL, and go a little bit into here. Basically, the template SQL, you have to modify it, remove some joins to different dimensions that are not involved really in trying to figure out the source data. You have several dimensions within Essbase that won't apply in this case to the source system. And then also, whenever you're doing the custom SQL, you can transform some of the column data as you need for reports. And this is kind of a sample of the original template of the template SQL. And in this case, you can see where we have the old fact table and a mapped table, but you see how these dollar entity columns and values, that's some of the predefined items within the template SQL, and a lot of that you can remove. You'll remove joins to, but that's how it actually passes the data. When you right-click on a cell, it knows, hey, this is the entity, this is the period, this is the product, project, and etc. It passes them into these values. Well, in this case, product didn't matter to us. Scenario, version, a bunch of those things didn't matter, so we removed those joins whenever we go forward and create our custom. And here's how the custom SQL looked. We actually, in this case, another point was that LD Studio Fact V was the original fact view that we had when we loaded the ASO cube, when we created it with just dummy data. There's a mapped ASO fact view that we actually had that was at that time was the one we used to map it. We included, by adding that as a potential source of data, we got it into the template SQL, so now we can leverage it later. And here you see how we removed the old the ASO dummy sample fact view. We have that. We removed that one, and now we just have the one that we have that's actually mapped. So and then you can see how we filter down the where, the join and the where. Those are important to leave as they are with the dollars, the format they all have. You don't have to have them all in there, but you have to have the ones that you care about. And but whenever Studio is going to issue the SQL command to the database, that's where it substitutes and replaces the column names and then also the currency values. So it'll do an in clause, and it'll say if you passed in potentially multiple, say, periods, it'll put list each of those periods in your in clause in the SQL, so it can have the multiple ones show up. Let's go to the next page. So this is a second example for this, and you can see at the top how we have we're pulling the actual some of the ASO account name and everything. The items at the top, you should have the same columns. You can define those columns as you're building your Studio drill-through report. But you'll see both the DAX. I can provide both the DAX accounts, the DAX entities, the ASO account. I can go and pull the account name, which was a DAX item. I can manipulate the amounts into the format that I want. I can pull in, like here, one of the keys that they really liked was we could pull in who was the one who reported this data and submitted the data, and then who approved the data. So all of these extra columns that you can get from your source system is what they were looking for. And that was a key to their, really to their success with this project. It's been live for over a year and a half, and the return on investment is very high. As you can imagine, before they had to flip through many different web pages to get down to the actual amount. They would start out in Essbase. They would identify some dimensions that they needed to look into, and you know, a set. Then they would have to go back over to the Microsoft DAX system, and then they would start drilling through and have to type in each of those individual dimensions and to actually get down to the set of data that they needed to look into. Let me see, I think most of this has been covered. Yeah, so let's go ahead and go to some of the questions and answers. I believe Shanna has some waiting for me.
Yes, I do. And before I read them off, just a reminder to everyone, if you have questions, just type them in the question box and we'll read them off to Michael and he will give you an answer. So the first one is, how do you add drill through to the cells? And this came right when you switched over to the PDF.
Yeah, and that's where I'll pass that on to Ron. That's a lot of what he did, was the actual Essbase Studio and that's you. So I'll pass that on to him.
You really are adding drill through to the report, not to each individual cell. In Studio, you create drill through reports by picking the dimensions, and levels that you will have drill through on. You define the intersection, and you can define the intersection with individual members depending on how you've built the outline, or you can do it on generations or levels. So when you pick all or a subset of the dimensions, and let's say you just pick a generation, that creates a range of intersections, and those intersections you can turn a style on so that those intersections will be flagged with a particular color. So the way you determine what cells are drillable is by defining the intersections in Essbase Studio.
Okay.
Let me see if I can zoom in a little more on this. This, unfortunately, I left this as kind of a fuzzy one because I didn't want to have too many details. But let me try to zoom in a little bit more on this, if I can. It's not cooperating, of course. But in this one, in the case like Ron discussed, you're actually inside Essbase Studio. Here's where you're actually defining the drill through report. It's associated with basically the studio with this cube, if you will. You actually create the drill through report, and then here's the actual account statement drill through report. In this case, you add in some columns and the display names you may want, and that's where you get your template SQL. And then here you can see just barely in this side here, if you were clicking on that cell, it pops up the drill through reports that you can select to run. And I believe in this case the yellow cells are the ones that you can run a drill through report from. But this here is smart. Yeah, the style
that's a style in Smart.
Yep.
And it was the context tab in that previous screen where you would set the you can't see the context tab here.
Yeah.
But
yep.
That's where you would pick your generations or levels to apply the drill through to.
There any other questions?
Yep, we have a couple more. So the next one is, what's the backend database for FDMEE? Is it relational?
Yeah, it's a relational. They use Oracle, and I believe you can also use SQL Server, because we were actually on SQL Server in this case. But you can use either relational databases. That's largely determined by your organization, obviously. and this code and this solution doesn't care which one you use. You obviously have to change a little bit of your code and how you do it, but that's normal between the two. But they can both handle it without any problem at all.
All right, so the next question is this for Hyperion Studio 11.1.2.3.891? How do you get SQL?
Should be a good bit, but the Studio should be the same up through now. This was actually done. They're running it right now, and they did an upgrade a year ago to one of the latest versions of of the Hyperion tools. I guess, could you repeat the last part of the question, the SQL?
Yeah, so the last part is, how do you get to SQL or other sources?
There's a setup. In Essbase Studio, there's a setup tab, if you will, that asks you to designate your server. For example, in the MS SQL world, you'd tell it that it's MS SQL. You'd give it the name of that server. You'd give it the database name. I believe for Oracle you have to give it a port. I don't remember if we gave it a port for MS SQL, but now that I think about it, you probably do. And then there's a test button to test to see if the connection was made.
Yeah, and this here is the Studio, kind of one of the bigger views. It has a lot of the items involved, and on the right, this of course shows data sources, and that's typically where you would set this up like you would in any of the other tools. You could create an ODBC connection, for example, in your system, and then you would actually tell this about that connection, and then you could leverage it from there. But I would caution you in what kind of sources you're trying to drill back down to. Typically, if you're doing this, you probably have access to Oracle or MS SQL. So if you're trying to go and access, for example, an Access database or some files, things like that, I would pull them up into the database and leverage the speed and efficiency and index capabilities, et cetera, of kind of consolidating your data together. But yes, you can define different data sources here within Studio.
And by the way, on the right, those sources are all perfectly visible. You can sample data. You get a great view into your source data, and then you essentially just drag and drop. You'd see columns on the right if you expand it all the way, and you just drag those columns over to the far left, and then you can do manipulations of them. There's a pretty good handful of functions for parsing and recombining and filtering, and then you'd have what they call dimension elements. Those dimension elements are sort of members, and you assemble them into hierarchies, and that's all reusable. One of the great things about Essbase Studio is that all of that groundwork is reusable across cubes. So it's a very, very productive environment to build in.
Yeah, we've used Studio quite a bit because it really is designed to make your life easier in building cubes from various sources. A lot of times people will go back to, you have a data file, you have some dimensional files, you build up your cube. People tend to live in the, EAS world, if you will, and just do it using load rules and things like that. This is definitely a strong option as well to build some of your cubes, and it provides a lot of flexibility. And in this case, of course, the drill through is what we were looking for. So this was one of the better tools for that. And as I said before, they leveraged this opportunity to implement DRM as a source for their metadata. They saw, of course, the value in that. And then our data itself, we just had sample data in this fact table, and we still are using, going back to actually a different relational source, or a different schema actually within this relational source to pull the actual data and to do that mapping and the views and all that stuff. And one other note is that FDM in this case is sitting off in its own box. It's working and feeding HFM. That's one of the things within part of the code is we extracted those maps and we actually loaded it to this other SQL Server schema and box that had all of the DAX data loaded into it. So moving it from one environment to the next, one box to the next isn't a problem either. Your maps usually aren't, are a reasonable size, and you can also do that in as frequently as you really want. So you can manage the amount of data being moved, etc. We actually have within here a process that replaces like a monthly mappings, if you will. You can rebuild the whole thing, or you can actually limit it down to a smaller set. They've actually sped this up to where now they're trying to do almost in essence near real time, where it comes, they try to pull in those maps. Anytime a new map's loaded, they replace the map that was already there, and their goal is to make all of those maps available all the time, so that when you're drilling back, because you have to have the map in order to drill back to the data, so they're trying to keep that as fresh as possible, so that as they're actually closing a month, they can do this drill down back and do their research for that current month as they're trying to close it out to identify some of the issues and all that. They've sped it up and really are leveraging this quite a bit in that process. Is there another question?
I do have one more question, and again, just a reminder, if anybody has questions, type them in the question box so we can get them in the queue. The next question is, if I have a cube that was not created in Essbase Studio, can it be imported in so I can use drill through? Does it have to be built in Essbase Studio?
Well, that's actually exactly the situation we had. Their original cube was not built in Essbase Studio. So we used the Applied OLAP Next Generation Outline Extractor to pull the dimensions, and that gives you a really nice, in our case we used parent-child file in each case, and dumped that, imported those dimension files into SQL, and then it was very easy to just drag and drop those columns into hierarchies, assemble the hierarchies into a cube, and deploy the cube. So there was work to do there, but it was pretty straightforward work.
Yeah, basically you need Essbase Studio obviously to do the drill through, but as Ron said, you can pull in the dimensions into the star schema. That's pretty simple. You don't have to have the real data to create the cube. Obviously, when the data that's loaded into the cube, and as was done here, was outside of entirely outside of Studio. It never was in Studio. And then when you create the custom SQL, that's when you can really redirect it to somewhere else and join it and pull it. So yes, you definitely, as we did here, you definitely can do it. Ultimately, you have to have Studio involved in order to do the drill through. It's just you really don't have to go through and originally have built this cube that way. And the data itself never has to reside in Studio. Are there any additional questions?
Yep, we have one more question. How does security flow from the summary to drill through transaction? Here I mean data level security.
Yeah, that's one thing that you're going to have to you have to manage very tightly. You're going to have to manage some of that within Essbase. You are connecting, and it's a really good question, because you are connecting as a single user, basically an Essbase Studio user, to the backend data. So in our case, we didn't have to deal with a lot of that because it was financial users on the high end that were using this. So they had access to all the data anyway within DAX or outside of and in HFM, et cetera. If you did have some of those concerns, you would have to look at a way to either pass in the real user, which I really don't know. I'd really have to look and see how you could do that. You may be able to set up different connections within Studio and provide different connections to the cube, depending on the groups. If you had a lot, obviously it'd be a problem. But if you had, for example, two groups, one, the financials that could do everything, another that couldn't, you could only see a small set, you potentially could set up a different, basically it would be almost a different studio, like a copy of it, but you would use a different database connection that has the more limited user in that connection. And then you potentially could do some more of the security that way. But you would have to get creative with that, because right now it does use one connection for everybody and doesn't distinguish between the users themselves. On the Essbase side it does, and you might be able to lock down some of the, well, I'll have to defer that to Ron, because I know we also had some, we looked a little into that, but we didn't have to have that problem, thank goodness. Do you know on the Essbase side, can you limit who can drill through the different cells and leverage some of the Essbase security for protecting that data?
If I remember this correctly, the ability to pass a user at connection time, at drill through time, was implemented in a new version right around the time we were implementing. I don't remember it clearly, but I think when you drill, there's a couple of layers. Either there is a user that essentially is the gateway between the Essbase user and the relational database. And I believe they implemented the ability to pass that user at drill through time right around the time we were delivering this. I'll have to check on that. If somebody wants to email me, that's rmoore@topdownconsulting.com. I will check on that and get back to you.
Okay, looks like we have no more questions. So we can go ahead and close the broadcast. Thanks to everyone for joining us. Michael, Ron, do you have any last comments to make?
Just thanks for joining.
Yeah, thanks for joining, and please feel free to reach out to us, because I know this is pretty technical and fairly dry, and we'll be happy to work with anybody if you want to have some more details or some more additional discussions, because it is a unique solution, and it also can be applied in different ways, because one of the other ways we did it is using that back-end mapping. You can actually, we used it to load data and bounce it off that mapping. If that mapping wasn't changing, you can use it instead of having to load through FDM and FDMEE all the time. You can actually use that back-end mapping to load, for example, into some of the cubes and things like that. We did it for kind of a system that was more of a reference system at a client, that they were not changing anything really in that system. So once we loaded or at least any of the mappings, any dimensions, so once they actually had loaded that mapping through FDM and FDME one time, we actually loaded quite a lot of the data through just the relational back end into their cubes, and that actually saved some time and effort. And then if there ever was a change, they just made sure they loaded up, and it was a mapping where you just put like 1 in the data. You didn't care what was in the data. You just loaded it up so the mapping was there. So there's actually a lot of different ways you can use kind of this this back end of FDM and FDME. Of course, we should probably put in a disclaimer saying that Oracle probably doesn't like us doing this, but it's one of those things that we found that we can leverage, and we're going to take advantage of it where we can. So, but thank you very much for joining, and feel free again to reach out. We'd be happy to discuss this and give you any more information and help you to further your understanding if you need any additional help. And everybody have a great day and a great weekend. Thank you for coming.
Thanks, everyone.